Coordinate systems, I'm sure you've used them, but did you ever wonder if you can define one? Think about it. We can create one, say for example, that has a rotation. So how's this rotated system defined? The directions of x and y are not aligned with x and y of the other system. So let's use vectors to define. Call the x1 right and the y1 up and put them beside each other. Yup, what we have made is a 2D matrix. We could use it to rotate a model like this. Suppose there's a point at 2x, 1, y, where not we take two rights, one up, add them, then we got the value of that point when it's been rotated. A transformed vector we've calculated. In games, a matrix is only really four vectors placed beside each other neatly. Use them to define rotation, scales, projections, and translations. This also works for scaling, and with a few extensions all this works in 3 dimensions. But what if the systems are in different places? We'll need another vector so we can translate this. We can add another column to our 3D matrix, but to use this we need another value in the mix. We need to use something called homogeneous coordinates. Basically we just add a 1 to the end. It's an elegant way to make it all work, and it also gives us another perk. We can use this value for projection and clipping, adding perspective when rasterizing. In games, a matrix is only really four vectors placed beside each other neatly. Use them to define rotation, scales, projections, and translations. Matrices can be transformed by each other. The simplest way to think about this is to consider each matrix as the vectors it's made from. All we are doing is transforming each of them so we can combine any number of matrices into a single one with ease. Coordinate systems themselves can vary, but please don't let this concept seem scary. The 2 core types are right and left-handed, which just means does Z go in or out, to be candid. In games, a matrix is only really four vectors placed beside each other neatly. Use them to define rotation, scales, projections, and translation.